Hey there, Seahawks. This is Miss Adams, and today we're going to talk about writing algebraic expressions to match real-world situations and basic introduction to polynomials. So our first problem, it says, you and your friends are going to Busch Gardens, and you are going to buy the refillable souvenir cup for fountain drinks or icy refills. On the day you purchase the cup for $14.97 after tax, your refills are free for the rest of that day. On future days, it costs $1.06 after tax for fountain drink refills and $2.13 after tax for icy refills. Use an algebraic expression to describe how much you will spend after tax based on purchasing the cup and number of refills after the first day. Okay, so after the first day, we already know that the cup on the first day cost $14.97, and then there's no extra costs after that for day one because everything's free. But after, when you go back after the first day, it's going to be $1.06 for every fountain drink refill. So $1.06, and I'm going to use the variable f to represent fountain drinks. And then it's $2.13 for every icy refill. So I'm going to say plus 2.13 I, and I'm going to use the variable I for icy refills. So there's my algebraic expression. Okay, part B. If you purchase and use the cup the first visit, then come back again and get 4 fountain drink refills, how much will you have spent on drinks after tax? So here's our algebraic expression, and we're going back the second day and we're going to buy 4 fountain drinks. So I'm going to plug in 4 for F. And I'm not buying any ices, so I would plug in 0, or I would just leave that part out. And when I do 1.06 times 4, I get 4.24. And when I add them together, I get $19.21. Now remember, this is a real-world problem, so when you get your final answer, make sure to go back and add in those things like the dollar signs. All right, part C. A friend meets you at Busch Gardens, and he already has the cup from his last visit. This time, you get 2 icy refills and 3 fountain drink refills. How much, or he gets that, how much has he spent on drinks at Busch Gardens? Total. Okay, so again, here's our equation. It's going to be the same equation for him because he bought the same cup and he's getting the same kinds of refills. So he got 2 icy refills and 3 fountain drink refills. So for I, I'm going to plug in 2, and for F, I'm going to plug in 3. So again, F, I'm plugging in 3, I am plugging in 2. When I multiply 1.06 times 3, I get 3.18. And when I do 2.13 times 2, I get 4.26. And when I add all of these up, I get $22.41. So far, since he's been to Busch Gardens and bought the cup, he spent $22.41 on drinks. Part D, write an algebraic expression to show how much money you and your friends have spent on drinks combined by the end of your second visit to Busch Gardens. So of course you could go back and look at the totals that you spent and your friend spent and add them together. Or we can write an expression, which is what they're asking, so that's what we want to do. So it's 2 times the cost of the cup plus 7 times F, because all together we bought 7 fountain drinks. You bought 4 and your friend bought 3. And then 2 times ices. Only your friend bought 2 icy. And then if I plug in the values for each of those, the cup was $14.97, so for C, plug in $14.97. Each fountain drink refill was $1.06, so for F, I plug in $1.06. And each icy refill was $2.13, so I plug that in for I. And when I multiply each one and add them up, I end up with $41.62. All right, write each phrase as a mathematical expression. The product of a number and 8. So product tells us to multiply. So it'd be 8 times n. And you can use symbols, parentheses, but it's not needed when you have a variable. 7 less than 4 times a number. So less than is one of those tricky ones where you want to be careful. It means you have to subtract it after your other thing. So 7 less than. So I'm going to take 7 away from something else. 4 times the number. So 4 times the number is 4n. And then I'm going to do 7 less than that. So I'm going to take 7 away from it. 11 divided by twice a number. So I'm going to start with 11, and I'm going to divide it by 2 times a number, so 2n. 16 decreased by a number. Decrease means to subtract, so 16 minus some number, n. The sum of 4 and a number. Sum means to add, so 4 plus n, a number. All right, this one. You're depositing $20 a week into a bank account with a current balance of $300. So you're starting with $300, and you're adding, deposit means to add money, $20 a week. So 20 times W. W will represent the number of weeks. This one, you save $30 a week. How many weeks will it take you to save $1,200? So this one is actually an equation. It's not an expression. An equation has an equal sign, and it has to be balanced on both sides. So I have $30 a week, and I want it to equal $1,200. All right, create a storyline or word problem using the following algebraic expressions. So you can get creative here. I'm just going to give you some examples so you know what types of things I'm looking for when you do some of these problems on your own in class. So 35 minus 5b. So you have $35 in your wallet. Burgers cost $5 each. Write an expression to represent how much money you have after you buy B burgers, where B would represent the number of burgers purchased. 750W. You send 750 text messages a week. Write an expression to show how many text messages you send in W weeks. All right, now polynomials. There are different types of polynomials. You can have a monomial, which is just one term. An example could be 5x squared. So that whole thing is one term. A binomial has 2 terms, and it would be like 8x plus 2. And a trinomial has 3 terms. It would be 4x squared plus 2x minus 1. So your terms are going to be separated by addition or subtraction. And a polynomial would be 4 or more terms. Really, all of them fall under the branch of polynomials. So here's an example. Then for standard form of a polynomial, the variables need to be in alphabetical order, then by highest degree to lowest degree. So alpha order first, then largest degree to lowest degree, and the degree is like the exponent. All right. Are the following expressions polynomials? If so, name the type of polynomial and state the degree. If not, justify your reasoning. So 5x squared, y to the 4th. So yes, and this would be a monomial. Okay, and then 4m to the 3rd and over 3n squared. So polynomials cannot have variables in the denominator. And the denominator is the bottom half of the fraction. So there's a variable. The letter n is a variable, and it's in the denominator, so that would mean it is not a polynomial. Okay, the next one, I have 12a squared b to the 3rd plus 5a b to the 4th c minus 4a squared. And that would be a polynomial, and it would be classified as a trinomial because it has 3 distinct terms separated by addition or subtraction. And D, I have 5xy squared minus 2x to the negative 1, y. So this would not be a polynomial because we cannot have negative exponents. All right. So this one, I have a polynomial, and I'm going to answer these questions. So I'm going to write the polynomial first in standard form. So these are all using just the variable x. So I'm going to put them by highest degree to smallest degree. So I'm looking at the x with the largest exponent, which is x to the 5th. So that one's going to go first. I'm going to have negative 2 x to the 5th. And then I don't have an x to the 4th. My next one's x to the 3rd. So plus 4x to the 3rd. Then I have a positive 5x squared. So plus 5x squared. Then I have a positive 3. Remember, when you're putting them in order, you always have to bring whatever symbol is in front of them. So for the 2x to the 5th, it had a subtraction sign in front of it, so it needed to go to the front with a negative sign. What is the degree of the polynomial? So I need to look at the front if it's in standard form. the largest exponent that it has, so it's a 5th degree polynomial. How many terms are in the polynomial? Okay, so the terms will be separated by addition or subtraction, and there are 4 terms. What is the leading term? Leading term means if it's in standard form, what's the first one that you wrote? My leading term was negative 2x to the 5th. And the leading coefficient is the number that's in front of the variable. Is a coefficient? So my coefficient would be negative 2. Okay. So this one, I don't just have the same variable. I have A, B, ABs. So I'm going to have to make sure it's in alpha order first. So when I put it in standard form, I am going to go A, just A by itself. And the only just A's that I have are 4A to the 2nd power. And then I'm going to go A's with B's. And I'm going to put them highest degree first. So I have a 3A squared B, and then I have a negative 5AB squared. So since I'm going in alpha order, A, the biggest degree, is going to go first. So 3A squared B, and then negative 5AB squared. And so then I'm going to go to my B's. I have a 2B and I have a B squared. So I'm going to go highest degree to lowest degree. So biggest exponent to smallest. So B squared and then plus 2B. And now it's in standard form. The degree of the polynomial would actually be 3. So you're picking the highest degree. And so that comes from in the 3A squared B. B is to the 1st power, and A is to the 2nd power, and when you combine them, it's to the 3rd power. Okay, and then the other one, the negative 5AB squared, that one's also to the 3rd power, because A is to the 1st power, B is to the 2nd, and combined, it's to the 3rd power. So the highest degree is 3. How many terms are in the polynomial? So this polynomial has 5 terms. The leading term is 4A squared, which means the leading coefficient would be 4. All right, so that's it for this video.